How are you, my friends? This is lecture number 21 of the Calculus 1 lectures. Indeterminate forms and L'Hopital's rule. In the objectives, we will see two types of indeterminate forms, 0 over 0, infinity over infinity, and we will apply L'Hopital's rule, which is a very powerful rule in finding the limits. Indeterminate form is a certain type of expression where the limit is not evident. So we cannot decide the value of the limit. Sometimes, like if we have the limit of the function f of x as x goes to a is equal to 0, and also the limit of g of x as x goes to a also 0, then the quotient f over g has indeterminate form 0 over 0 at x equals a. So what do? We take the limit of f of x over g of x as x goes to a will be the limit of f prime of x divided by g prime of x as x goes to a, provided that the limit on the right side here should exist. So that is L'Hopital's rule. Remember, it's not the quotient rule like normal, just the derivative of the function f in the numerator and the derivative of the function g in the denominator. Let's see, find the limit of sine x divided by x as x goes to 0. We know the answer, but we need to use L'Hopital's rule. We know this is the basic trigonometric limit. This is in lecture 4. Let's see here. If we try to find the limit of sine x over x as x goes to 0, so we apply the limit laws here. So it will be sine of the 0 over 0 itself. So that would be 0 over 0. So we call this indeterminate form. So we need to use L'Hopital's rule. So what do? The limit of sine x over x will be the limit of the derivative of the sine x over the derivative of the x. The derivative of the sine x will be cosine of the x. The derivative of the x will be 1. So now we can replace x by 0 using limit laws. Cosine of 0 will be 1 over 1, which is 1. And we know the limit is 1. Let's see another nice example here. The limit of e to the power x minus 1 divided by sine of 2x as x goes to 0. First, we try to check the L'Hopital's condition. Is it indeterminate form or not? So we replace x by 0, e to the power 0 minus 1. This is e to the power 0 is 1 minus 1. Sine of 2 times 0. Sine of 0, 0. So this is 0 over 0. Yes, it satisfies. So we can use it now. We can use L'Hopital's rule. The derivative of the numerator divided by the derivative of the denominator. So this will be only e to the power x. This will be 2 cosine of 2x. Just review the derivative rules. Now we will have the limit of e to the x, e to the power 0, 2 cosine of the 0, e to the power 0 is 1, 2 is there, cosine of 0 is 1. So the limit here will be half the answer of this question number 2. Question number 3, we have a little long question here. Find the limit of 1 minus x plus ln of x divided by 1 plus cosine pi x as x goes to 1. So as usual, we try to check the L'Hopital's condition. So I replace x here by 1. So 1 minus 1 plus ln of 1 divided by 1 plus cosine pi times 1. 1 minus 1, this is 0. ln of 1 also 0. Cosine of the pi is minus 1, and there is a plus 1 here. So 0 over 0. Yes, we can use L'Hopital's rule. So let's find the derivative of all this. The derivative of the 1 is 0. The derivative of the minus x is minus 1. The derivative of ln of x will be 1 over x. This is the derivative 0. Cosine of pi x will be minus pi. This is the coefficient of the x here. Sine of pi x. Let's replace x by 1 here. So minus 1 plus 1, that will be 0. Minus pi sine of pi, also that is 0. So 0 over 0 again, L'Hopital's condition satisfies again. So we can use it again and again. So we have to find the derivative now. Minus 1 plus 1 over x, all this, the derivative of that, minus pi sine of pi x, all the derivative. This will be here, the derivative will be 0 for the minus 1. 1 over x will be minus 1 over x squared. We leave here the minus pi, and there is another sine pi x. So there will be another pi cosine pi x. So it will be minus pi squared. Now let's replace x by 1 here. So we get minus 1 over 1 squared. Minus pi squared cosine pi times 1 will be cosine of the pi, which is minus 1. So we have minus 1 divided by minus pi squared times the minus 1. The final answer, the limit will be minus 1 over pi squared. Another indeterminate forms involving infinity. So if we have the limit of the function f of x, x goes to infinity is infinity, and the limit of g of x as x goes to infinity is also infinity, then we can use L'Hopital's rule. Okay, that's an example. Just one more remark here, I did not say. Also, we can have the limit of f of x as x goes to a if the answer is plus or minus infinity, and the limit of g of x as x goes to a also is either plus or minus infinity, then we can use L'Hopital's rule. We will see now this nice example here. See, we have the function y equals ln of 2x divided by ln of x. That's a function. Find the value of limit of y, all this function, as x goes to 0 from the right side. Why from the right side? Because the argument here should be positive. So x here is positive, cannot be 0. From 0 open to infinity, the domain of this function. So let's see now. I put here just to refresh your memory, the function ln of x by itself, y equals ln of x just by itself. This is the black graph, the increasing, the base is e here. ln of 2x, that's another function. This is the blue one. See? Very similar, that's logarithmic function base e. Now we have another function here. The whole function is the division. It's another function. See, this black one is the graph of this, our function given in the question. Y equals ln of 2x divided by ln of x. That's another function. This is the function here. Now let's check L'Hopital's condition. What will be the limit of 2x? See, limit of 2x as x goes to 0 from the positive side. It will be minus infinity. See this one in the blue, it will go down. See, this is 0. 0 from the right side, it will go down to minus infinity, divided by the limit of ln of x. This is the black one, separate. If you come to 0 from the positive side, this will be down to minus infinity. So this, the L'Hopital's condition satisfies here. So we can apply it. So the limit will be ln of 2x prime divided by ln of x prime. This one will be, remember the rule, u prime over u. So the derivative of 2x is 2 divided by 2x. And here only the derivative of ln of x will be 1 over x, which is 1. So the limit of all this given question is 1. Let's see the same idea here, same function, but we need to find the limit of y, which is this function, as x goes to infinity. So please, when you study example 5, compare it with example 4. The same function, one time we are finding the limit as x goes to 0 from the right side, and this one as x goes to plus infinity. See the same functions, same graphs. Now, if you check here L'Hopital's condition, ln of 2x as x goes to plus infinity, that means we are increasing the x here. So look at the black function here. What will happen? It will be plus infinity. It will go to plus infinity. Same thing here. The black and blue, each one will go to plus infinity. So we can use L'Hopital's rule. Same idea, ln of 2x prime divided by ln of x prime. So the answer also 1, but this 1 is horizontal. If you remember, this is horizontal asymptote. If you find the limit of a function as x goes to infinity, and you find an answer there, the limit is L here, which is 1. So y equals 1 is this blue here, the horizontal asymptote for this function. This vertical asymptote, you can get it from the denominator here. What will make the denominator 0? Only 1. So x equals 1 also is a vertical asymptote. Let's see another one. Find the limit of ln of x divided by square root of x as x goes to infinity. Check the condition. Let's check the condition here. ln of x as x goes to infinity, we know the graph, it will be plus infinity. Square root of x also as x goes to infinity, it will be, it will be plus infinity. So we can, the L'Hopital's condition here applies. So we can apply the rule. The derivative of ln of x will be 1 over x. The derivative of square root of x will be 1 over 2 square root of x. So we have a division now. You can use this important rule from algebra. A over b divided by c over d will be a over b times d over c. So you can do that here. Then you can rationalize to simplify it more and more. See, square root of x will be x, cancel with this. So the final you will have here the limit of 2 over square root of x as x goes to infinity. So if you replace this one here, it will be infinity. 2 over infinity, the limit will be 0 for this function, the given one. Please always check the playlist, Calculus 1 solved questions, to see more and more questions to understand the lectures better. Now, this is the end of lecture 21, L'Hopital's rule. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.